So today is about inscribed angles, and like that's just a fancy schmancy word for like if the vertex of an angle is on the circle. If I could select my highlighter, that'd be awesome. But check it out. Do you see this angle that's in the picture right here? It's angle ABC, and I got to ask you this question. I'm going to preview next time. There's only 2 lessons left in this whole year. Today is about inscribed angles, and next time is about a couple of different angles. I'm going to ask this question all day, and if you can ask yourself this question, you will dominate this test. You see this pink angle that I have highlighted? Last time, the vertex of that angle was on the center of the circle. Are you with me on that? Not today, right? How do you feel that he is on the circle? But there's 2 other places it could be. That'll be next time, is inside the circle or outside the circle. So there's only 4 possible places. Where is the vertex of this guy? Inside, outside, on, or center? You guys tell me. The answer's on. Where is the vertex of this angle right here? It's on the circle. It's got a fancy name of an inscribed angle. I honestly don't care that much that you know what that's called, but ACT questions do use that word. It's like this is inscribed in this and inscribed in that. But here's the relationship. Check this arc out. You see that arc AC? That's what they're asking us to find also, the measure of arc AC. Do you see that that is contained by that inscribed angle? Like it's completely inside of it. Like if I was to highlight all of that, I never went out of bounds from that pink angle. You know what I mean by contained by it? Here's the ratio, 2 to 1. The arc is always twice as big as the angle that it is inscribed in. Do you see that angle is 36 degrees right there? So grab a calculator if you need it, and just take that bad boy times 2. What would be the measure of arc AC? Yep, and here's a secret. The questions will get harder. We're going to start by baby stepping. Put the 72 in the picture, and then go put it in the blank. And if you can put them in the picture, you will make your life a whole lot easier. Right? So that's a 2 to 1 ratio. But I'm going to keep just drilling this through your head. Here is another angle that's going on in this problem right here, and the magic question is, where is the vertex? Inside, outside, on, or the center? Where is the vertex of this guy? He is on, means 2 to 1. On the circle is 2 to 1, but hold, boom. Who is this? The arc or the angle? Who is that guy right there? That's the arc. So we might not always be multiplying by 2. Sometimes we might have to divide by 2. Does that kind of make sense? Because the arc has to be bigger than the angle. So what do you want to do? Multiply or divide by 2? Divide. So 62 divided by 2 is 31. If you put it in the picture and you put it in the blank, we'll be in really, really good shape because the questions do get harder. And even though they ask us to find all these arcs and all this crazy stuff, to me it's all about angles in the circle, right? So again, I'm looking at number 3 here. There is an angle. I'm a highlighter kind of guy. Again, I don't care if you highlight. I'm not going to force you to highlight. I just like it so we could see things. So I highlighted that angle. It's even tough to see with this little bitty cord right here. It's so weird because the copies just don't come off very well. But it's got a vertex of P. Where is it? Inside, outside, on, or center? On the circle means 2 to 1. The arc that's contained by it would be this dude right here. Isn't that the arc that's contained by it? And check it out. Isn't that what they want me to find? The measure of arc QSR. So 2 to 1. Do you want to take it times 2 or divide by 2? Times. The arc is bigger, right? So 113 times 2. If you need to punch that in, go for it. But I'll bet you get 226 back on that one. How do you feel about that basic concept right there? Inscribed, 2 to 1. Now remember, we also had these. Where's the vertex of that blue angle? Inside, outside, on, or center? See, that's the central angle. That's a whole different story, right? So we're only talking about inscribed, where the vertex is on the circle. So like if this right here was 35 degrees, then this arc is 35 because central means same. Like central, same, inscribed, 2 to 1. Let's do this. There's 6 questions down here. You and your table group, let's do 4, 5, and 6, and then we'll check with each other, right? Just try that. Where is the vertex? Do you have a question? I got all these angles highlighted, and I just keep asking myself, where is the vertex? Inside, outside, on, or center? And how do you feel that this is on the circle, right? So that's a 2 to 1 relationship. This is 23. What should this one be? 11.5 or 46? 46 degrees, twice as much. And then what did y'all get for number 5, measure of angle E? We have the arc, right? See this big green arc is 162. Times 2 or divide by 2? Divide. Did you get 81 back? Those, again, were still pretty basic. We're just crawling right here, real basic. Number 6 is the first step up because they ask us to find the measure of angle R. I do not have this angle measure. That's what they're having me find. And this is the arc contained by it. They didn't give me that either. But boy, oh boy, could we figure out what that green one is. Is there anything we could do? What could we do? I'm hearing it. Go ahead. Do we have everybody else except for that green one, right? Isn't this the rest of the circle right here? Do we have the 120 and the 140 right there? And the green one is the only one missing. And by the way, how much do they all add up to be again? 360. So 360 minus 120 minus 140. And I'll let you tell me what that green arc measures. What did that green one measure? 100 degrees is correct. And now I'll give you 3 choices for what this angle could be. It could be 100, the same. It could be 50, half as much. Or it could be 200, twice as much. All of those concepts we've went over so far this chapter, which one of those is correct? 50, 100, or 200? Half as much, because it is inscribed in that, and the arc has to be bigger than the angle. Cool? 3 more of those. Get those done, please. 50 degrees. Please, if you learn to put them in the picture, you'll see on the next one it's a little more challenging. So putting them in the picture will help us. But this guy right here, vertex on the circle, how do you feel that that should be 62? But that's not the answer to the question, because they want the measure of arc MP. And isn't that pink one right there? You see how sometimes we just take for granted of what they're asking us to find. The measure of arc MN is 62 degrees, no doubt. Let's see if we can find the measure of arc MP. And here's the secret. A circle's best friend is a diameter. Do you have any diameters in this picture? Because the diameter means that's 180 in green and that's 180 in orange, correct? And if the whole thing up here is 180 and that's 62, can't you just do 180 minus 62 to figure that out? What is that, 118? Is that right? Or is it 108? 118. Thank you. It's Friday for me also. Brain's a little tired. So. Cool. So honestly, that's probably our largest mistake, is not answering the question that they asked. We just assumed they wanted that 62 and not that 118. And then measure of arc AB, he is 88 degrees. Are we okay with that one right there? And then the measure of angle X, where's the vertex? Inside, outside, on, or center? He's on the circle. On, 2 to 1. Right? 2 letters in the word on. On, 2. 2 to 1. Right? 2 to 1. So 180 or 45? 45 with a pen would be better. How do you feel about those? Those are, again, very basic. That was just a setup to answer. Oh, my bad. Here's some ACT questions. These are super secret, and then we'll get into the big combo questions. But I threw these in here because these are really cool. They say, hey, find X, find angle W. Well, here's X. I know that what's bad about this question, they also have a large X for one of the letters right there. We want the little one, right? So they say find X. Cool. He's an angle. Please don't highlight. I'm just going to show you what's going on right here. Then when I'm all done explaining, you could probably highlight. But here's how I start. There's that angle that X is in. Answer this question with your group. Where is the vertex? Inside, outside, on, or center? Where you got? On. Anytime you ask for help on homework, that'll be the first question I ask you. Where's the vertex? So might as well start doing that for yourselves. Inside, outside, on, or center. So he is on the circle. This is the arc that is contained by it. Ew, they didn't tell me that either. This little x plus 12, you see the arrow? It's kind of hard to see that, but the arrow's pointing. That's this angle inside of here. All right, so ew, I don't have either one of these. So I'm stuck. So I go to the circle's best friend. Who is the circle's best friend? Diameter. Do we have one? Sure do. And here's how the circle's best friend helps us out. How much should that green arc right there measure, my friends, knowing that orange thing is a diameter? I caught him green this time. How much? Put him in the picture. You'll thank me later. That is 180 degrees. And I would say even a struggler with geometry can get that in the picture. It's like, I get that, you know. It's like, I know that's got to be 180. How does that help me? Well, if we get stuck again, we'll get to that in a second. Here's how that 180 helps me. Like, who's the, like, ends, quote-unquote, ends of this semicircle? Like, what would be the name of that arc if you called him? Arc what? Arc what? WX. So watch this move. I'm going to kind of just erase for a second to make it clear. If you do this sometimes when you get stuck, you see how W is the end of that guy and X is the other end of that diameter? If you could trace a segment backwards, like I'm about to do right here, this is a weird move, but we'll get used to it. If I trace this segment backwards, starting from W, do you see how it ends at Y, if I did that? And if I did it again from here, did it go to the same letter Y again? I just made an orange angle in this picture. And holy cow, do I have a cool question for you. Where is the vertex of that orange angle? It is on the circle. And it is contained by a 180-degree arc, right? So how much should that orange angle measure? In this case, 180, 360, or 90? Shouldn't it be half as much? So let's throw that 90 inside of that picture right there. And what makes this an ACT question is that's not what they wanted us to find at all. It's like, why are we doing that? They didn't want me to find that, because sometimes you got to find something they don't want you to find what you do want to find. So let's get the best friend story out of the way. Who's a circle's best friend? Diameter. But now we have a new best friend. I've been trying to say this all year, but it just hasn't happened as often as I wanted to. Geometry as a course has its own best friend. The circle's best friend is the diameter. Geometry's best friend is a triangle. Do we have a triangle in this picture, yes or no? So when extra stuck, look for triangles. Sound okay? Why? Because we should know at least what all three angles add up to be. These three pink guys should always add up to be what if you are a triangle? How much? 180. This one is 90. This one is X, and even though they snuck it on the outside, isn't that one X plus 12? So I'm going to add them all up. Like X plus 12 plus X plus 90, they all should add up to be 180. And yep, you might be going, do we have to do it like that? That's the long way. Of course, don't we have to combine like terms right after this, correct? So you are definitely welcome to not do that step and combine like terms right away, because don't you just have to add all your X's together? How many X's are there total? 2 X's. Then you add all your constants together. Isn't 12 a constant? And don't forget about 90. Isn't he a constant as well, right? So 12 plus 90 is 102. Shouldn't that add up to be 180? Does that make sense how I just combined all the like terms? When we do any others, if you don't want to do that top line, you don't have to. Just go ahead and combine all the like terms. But holy cow, has it been a while since we solved an equation? Let's solve for X. I need to move this 102 over to the other side. How do you do that? Subtract. Grab a calculator if you need to. 180 minus 102. I got 78. Does that sound okay to you? So 2x equals 78. By the way, all this work shown, you'll have to show, right? And then, of course, I still don't have x by itself. There's this stupid times 2. How do you get rid of that times 2? Divide by 2. And holler out what you got. What did you get? 39. And there's the answer to the first question. What does x equal? 39. So we needed 2 sneaky moves. Number 1, we looked for a diameter, because that gave us that 180 degrees. And then where we really used that was getting this 90 in the triangle. Because boy, if I had all 3 angles of the triangle right away, I just wouldn't have to do all that other stuff. We needed all 3 guys of the triangle so we can add them up to 180. We did struggle with a question like part B earlier in the year. Let's see if we're better at it now. They say find the measure of angle W. Here is angle W's expression. Right here, isn't it the X plus 12? Do we now know what X is? What is X? X is how much? So substitute 39 in for X and figure out what angle W should be. You just do 39 plus 12 right there. And I think that's 51. Is that right? Does that make sense? Once you find X, sub him in. Rock on? Cool. Let's do that again. They want us to find little x in this picture. There's not even a little x. We've just got to set it up. And here's your buddy right there. What's that thing that I highlighted? He is the diameter. And I'm going to roll with a 180 right there. You could put it on the top too if you wanted to, but how did I know to put it on the bottom? Well, I guess experience, but it's also because there was no other like chords in the way of that 180, because I need to trace him back to that. Doesn't that 180 trace back to that angle S right there? Trace him back. So that should be 90. And then I'll let you set up your equation to solve for x. You could pause the video and get that done. So I just added up all my like terms. I had 6 x's, and then the 90 plus the negative 6 is 84. And then subtract. What is that? 96, is that right? And then when you divide, it comes out pretty nice. 96 divided by 6. 16 sound good to y'all? Cool. And then to find the measure of angle T, substitute 16 in for wherever angle T's expression is. It's right here. This 4x minus 6. So we're just doing like 4 times 16 minus 6. You see how where there was an x, I put a 16 in its spots. Right? And what'd y'all get? 58 sounds great, baby. Not bad, right? But boy, getting started on that on your own could be a tough one if you had never been taught circles before. It's like, yeah. Then one other big old boy right here. There's a test question like this. I haven't told you yet. The test is pretty short. It's the end of the year. We're all tired, you know, so it's going to be short, sweet, to the point, you know, not just some big old rigmarole. So keep fighting for me. But they say find the following measures of all this circle. Here's the way I'd like to approach it. There's definitely other ways to do it. I am going to ignore these questions again for a second. I don't care about those questions. I'm going to go to the picture and just put all the things I could find first. And I think it will make answering the questions easier for when these get tougher. So that's my strategy. There's other ways to do it too. As long as you get the right answer, we're okay. But here's how I want to go to this picture. I want to find any angles first. Do you see? There's also some arcs in there, right? But do you see any angles? Shout it out. Give me the number. What angle do you got? You got what kind of measure? See the 52? I think we should highlight that, right? Or maybe darken it with your pencil, one of the two. Like, let's just see what's going on here. Here's this 52. And if you could buy into doing this, ask yourself this question. Where is the vertex? Inside, outside, on, or center? Where is that 52? He is on. Then you got to go find the arc that is contained by that bad boy. Don't have to highlight it. You can squiggle it or whatever, but if you can just see it, how do you feel? It is that guy right there. How much should that measure? The same or 2 to 1? 2 to 1 because we're on, and doesn't he actually have to be bigger because the arc is always bigger? So times 2, how much is that green arc right there? 104 degrees. And I do know that's one of the questions that's over there. Who cares? I'm not worried about those. I'm going to put it in the picture. Because watch this. That was the only angle they gave me. The arcs are kind of confusing to most people, so I'm going to avoid those if possible. The next thing I'm going to look for is our best friend in the circle. Who is the circle's best friend? Boom. Right there. Isn't that a diameter? That was supposed to be a highlighter. Isn't this a diameter? What's so great about that? I'll bet you know how much that pink thing should measure. How much should that pink thing measure? 180. This little guy is 23. This little guy is 104. Could you find the missing piece to that puzzle? What you got? 53 degrees is correct. And by the same rationale, could you have done that down here as well? Shouldn't all of that be 180 degrees? And you know that dude right there was 48. 180 minus the 48. Does that make sense where I'm using the diameter to help me for the semicircles, right? You know, so what is that, 132? Is that right? Cool. And to me, if I could find all the arcs, which I have done, then I'm going to go back and try to start answering some of the questions. So I'm going to go answer the questions, and this is where highlighting or darkening with the pencil helps a lot of people. So I have the luxury of being able to erase my highlighters a little bit. They say find the measure of angle BDE. So I will highlight that. Let's use the color I haven't used yet, red. I'm going to go from B to D to E. Starting to get messy already because I have a bunch of other highlighters, but you see that red angle where D is the vertex, from B to D to E. Here's the question. Where is the vertex? Inside, outside, on, or center? On the circle. He's right there. Do you know the measure of the arc that's contained by it? Yes or no? We know all the dang arcs now, right? So we should, right? So what do you want for this guy? 48, 24, or 96? Half as much, 24 degrees. Go put him in the picture. 2-to-1 relationship on that bad boy. Honestly, the hardest part is just seeing what's going on in the picture. Like, I think you know the rule. It's like, okay, I can't see this angle. Next one, I need help. It's been a while since I've had you say it. What does that even say? That I highlighted. What does this even say? Tell your group. What does it say? Very good. Measure of arc CD. That should be in our picture already. Haven't we found all the arc measures, right? What is the measure of arc CD? 104. Once again, we went the short way around because they used 2 letters. Are we cool with that? You know? And then the last one, measure of angle DBF. Starting to run out of highlighters, so sometimes people take their pencil and squiggle a little bit. I'll do that on this one, from D to B to F. Where are we at? So from D to B to F. Do you see how I just traced D to B to F? Here's the vertex. He's on the circle, right? Do you know the measure of the arc contained by him? And it is okay if you get a decimal. So the arc contained by him is 53, and I need to do half as much, right? So how does that, what does that get for us? 26.5 degrees. Cool. Again, my way is not the only way to do these, but I have done enough of these in my lifetime where I know if I can just go find a bunch of stuff in the picture first, it's probably going to make my question answering life a lot easier in that case. Cool. And then one last quickie concept. This will go faster than you think. Check this guy out. If I highlight that segment, how many times does he touch this green circle? Once or twice? Once. That's called a tangent segment, right? Just once. Remember, secants go through it twice. Tangent just touches it once. Question on this orange one there that I have. How about this other guy? How many times does that segment touch the circle? Once or more than once? Once. Those are both tangent segments, and do they come from the same letter? Yes or no? They both come from C. Here's what this crazy theorem says. If you got 2 tangent segments coming from the same point, they have to be the same. So that orange one and that blue one are the same. Give me an E word. That means they are the same in mathematics. They are equal to each other. So set those 2 bad boys equal to each other. Do you see how I just did that? That's what the same means. They are equal. And of course, we'll solve that for x. Way too basic for us. What should x equal? 4. Let's do that again here. You see this is a tangent segment in red, and this is a tangent segment in pink. Do they start from the same point outside the circle? Those are the same lengths. And it's way too easy because there's nothing to even solve for. Doesn't it just say x is 12 in that case? And then before we finish this guy off for a worksheet, like in honors geometry, this chapter is 8 lessons long. There's a lot more but circles that we try to teach them, you know, because they had a little more time. Here's always my advice. We deal a bunch of segment stuff as well. If you were stuck on the ACT and you didn't know what to do with the circle question and you had a bunch of segments, I would say 9 times out of 10, you should just set them equal to each other, and it'll probably work. Even if you have no idea what you're supposed to be doing, if circles and segments, if you just set them equal to each other, it's probably right. Cool? Not every time, but it usually is. So we'll do that here. Fancy word of a circumscribed polygon. How do you feel that this thing right here is the polygon right here in pink? Like that is a triangle. And check out where the circle is. You tell me, inside it or outside of it? The circle is inside it, right? And how many times does the circle actually touch the segments, like there's 3 segments for a triangle. So he just does it one time, one time, one time. Are you with me? Like once each side length of that guy. That's called circumscribed. Weird word, but here's the cool thing. You didn't even really need to know that word to know this. See this dude right here is 13. He is tangent to that guy because he only touches him once. Is that orange one also tangent to it, and do they start from the same place? So if this is 13, what does that orange one got to be? They got to be the same. Right? Does that make sense? Like this is the same thing we were just doing. So see how this bro right here is 17? How long does that bro right there have to be? 17. Again, by putting these in the picture, it'll help us answer some questions down below. And if that dude's 10, how do you feel that that dude should be 10? Once again, my strategy would work. If you had no idea what to do, assume those are equal to each other, and it would be correct. But they ask us to find x. X is this whole big bad boy right here. Wouldn't x be that green one and that pink one, what it was supposed to be, like put together? So how long should that be? 23 is correct. And they finally ask us to find the perimeter of that original triangle that I had highlighted. I'll just do this whole thing in pink. I've had different ways I've had kids try to figure it out. I don't care which way you do it. Here's the way I prefer that I do it myself. I just take every one of these numbers right here and add them all together. That's all perimeter is. Just add them all up, and I should have 6 numbers that I added together. Some people try to find that length first, and that length, and that length, and then add those 3 together. They usually make more mistakes than just trying to add all 6 of them up, right? So just be careful because it's weird. Where did I start? You know, it's like just go around the clock. But when you add them all up, it's like 17 plus 13 plus 13 plus 10 plus 10 plus 17. Did I have 6 things that I am like adding together in that case is what I go check for. Did you get 80 back on that bad boy? Right, so it's so easy to do, so easy to make a mistake too, because it's like, did I hit the wrong button? Did I get all 6 of them in that case? So 80 what? I know they don't have a label like inches or anything, so we'll do units. But do you want units, units squared, or units cubed for perimeter? It's just units. Area is squared and volume is cubed, so this is units. We could probably stop here if it wasn't for one little twist on this guy right here on number 15. They want us to find x, so here's a trick. See how long that guy is right there? How long should that guy be right there? Also 18. Meaning, if this whole broham is 26, and this little part of it is 18, could you do some subtraction to figure out what that other one is? How much is that little guy right there? 8. Meaning we can just now find x. What does x got to be? 8. And of course, the last little guy right there in the puzzle is 14. And I'll let you add all of those puppies up again. And again, if you try to go on a dangerous road and use the 26, it's not that I'm going to stop you, but then my little add 6 things up doesn't work anymore because you just took 2 of them and put them together. So it's just add all 6 things up and see if you can get a number. And it is just a coincidence that it turns out to be 80 again this time. It doesn't mean they always have to be the same thing. We're okay with this? The magic question is, where is the vertex? Inside, outside, on, or center? Next time we'll teach how to do when it's on the inside and the outside. But all we know so far is on or center. Let us know if you have any questions. Have a good one.